So today we're going to talk about ggplot and the grammar of graphics. So ggplot was a package written up by Hadley Wickham, and it implements the grammar of graphics, which was written by Leland Wilkinson. And it's kind of Leland Wilkinson's grammar of graphics is kind of like this manifesto on data visualization, like if we think about like what it means to visualize data, what is that? And he put that in this formal system of well, that he called the grammar of graphics. Okay, but it's important to note that ggplot is not meant to be the be-all or end-all of graphics, and you have some very useful graphics tools, base graphics, plot and histogram and all of these things. These are very quick and they're very easy, and a lot of times I still use those things. However, I think as far as larger data sets go, or things with lots of variables, ggplot 2 puts into this structured system, which I think makes our lives easier and better as far as data visualization goes. Okay, and so if we're thinking about, let me refresh this. Okay, so in a data graphic, if you think about it, there is a mapping from the properties of the data to visual properties of the graphic. Okay, this is the key part of the grammar of graphics. We are mapping properties of the data, so values in your data, to properties of a graphic. Okay, and so data properties are things just that you store in your column of variables, right? You're going to have, people's weight measurements, people's height measurements, their hair color, their eye color, or their gender, or whatever else you might have. You're either going to have numerical, categorical variables. These are the data properties. And we want to map them to visual properties. Okay, so if you think about a graphic, the visual properties are things like the X and Y positions, the colors of the line, the heights of the bars, or the shape of the points, whatever those things, those are all visual properties. Okay, and it says, a data visualization that didn't map data to visual properties is not a data visualization. Okay, and it might, we're so often, when you created your first scatter plot, I imagine somewhere in 7th grade, or I don't know, middle school or elementary school. Okay, you learn this is the x coordinate and this is the y coordinate, and you're creating a scatter plot that way. But if you think about this, the position along the horizontal axis and the position in the vertical axis is just a visual property. It's just a visual property. That's it. It's no different than the color of the point that you're going to use, or the shape of the point. At an abstract level, they are just visual properties. Because we're so used to seeing x and y coordinate systems, there almost feels like there's an inherent difference, but there's not. They're just visual properties. Okay, and so if you've ever created graphics kind of from scratch, there's this maybe an underlying inherent understanding of this. Okay, all right, and so let's take a look at the grammar of graphics here. Okay, so and first we'll compare the grammar of graphics by comparing it to base graphics, and how base graphics you have special functions for each type of graph you want to make. And if you want to change the way this thing looks, you often have to reshape your data, or you have to use entirely new sets of commands. Okay, so here I'm just using this very, very simple data set called Simple Dat. This is from the gcookbook package. So if you don't have that, you probably don't have it on your computer. You're going to have to install that package's gcookbook if you want to follow along right now. Gcookbook is for the R graphics cookbook. Okay, and so this is available on Safari Books Online. So if you have not, go to proquest.safaribooksonline.com. It's free while you're connected to the UCLA network. So if you're at home, you got a VPN in, and then you just, in the search, you just type in R graphics, okay? And your first, or R graphics cookbook, and your first hit should be the R graphics cookbook. And I'm pretty much pulling a lot of content directly from this textbook, okay? Or it's not even a textbook, just kind of this manual. Okay, anyway, so this is our data set, and this is just a two-way table showing the counts for two categorical variables, right? We got categorical variable A, which has 3 settings, A1, A2, and A3, and we got categorical variable B, which has 2 settings, B1 and B2. And here it says there are 10 that are A1 and B1, and 9 that are A1 and B2. Okay, and so on and so forth. 7 that are A2, B1, 11 that are A2, B2, so on. Okay, and maybe we want to create a bar plot. Okay, so to create a bar chart with this, we just say bar plot simple det, and we'd use the option beside equals true, which doesn't stack the datas on top of each other but puts them side by side. And what this does is it puts the A categories, A1, A2, and A3, along the x-axis, and then the values 10 and 9 are represented along the y-axis. Okay, and then the color of the bars, whether they're dark gray or light gray, corresponds to whether it's B1 or B2. Okay, and this is using the base graphics command bar plot. What if we wanted to go the other way? Instead of having 3 groups across the bottom, A1, A2, and A3, what if we just want 2? We want B1 and B2, and we wanted 3, each group to have 3 bars. Yeah, to do this, we would have to transpose the data itself. We have to restructure our data so it looks this way. Okay, we would transpose that matrix, and then we would do bar plot of that transposed data. Okay, so changing the way the graph looks into something like this requires us to actually restructure our data. Okay, and here we have dark, medium, and light gray corresponding to A1, A2, and A3, and the 2 positions represent B1 and B2. So that's base graphics. If we wanted to do lines instead of bars, which is totally a legitimate way to do this, we would call the plot function. Okay, we would call the plot function, which tells R to create a new graph, and the plot will initially only be able to create 1 line for 1 line of data. And if we want to add a second line, we have to use the command lines. So plot creates the initial plot, and then we add a second line using lines. I'm going to show you the graph on the next slide right here, but when we take a look at it, we'll notice a few quirks. The second line is going to run below the visible range. Okay, so when we look at this, we see the blue line runs down here below the visible range. And the reason for that is because when we first called the plot function, it created its ranges based on the first row of data. Okay, so we said plot simple data row 1, we want type L, and it creates this thing. And then when we added the second thing, because this range was already created, when it's trying to plot right here the 6 for B2 and A3, it goes down here. You'll also notice that the horizontal axis has an index. Okay, so rather than saying this is A1, A2, and A3, it just says this is 1, 2, and 3, indicating this is the first, second, and third point. And it almost looks like it's a continuous variable, but it's not, right? It's categorical, but it's putting in 1.5 and 2.5, and maybe that doesn't bother us, but it kind of bothers me a little bit in that this appears like 1.5 is a legitimate value, and it's not. This is categorical. It's A1, A2, and A3. Maybe if we called it, red, white, and blue, it's different. It's not. They're not values. You can't have a 1.5, which I don't know what that would correspond to. Okay. So anyway, these are a few quirks of trying to use base graphics. And so if you wanted to do base graphics correctly, you would have to very explicitly state that the y-axis or the y scale needs to go from here to here, and the along the x-axis the labels need to be this, this, and this. Okay. On the other hand, if we wanted to do ggplot to create this, use the grammar of graphics, we first have to restructure our data into tidy form, okay, or long form. And this might be the hardest part of using ggplot, is that ggplot requires all of your data to be in tidy form. Okay, and so in this case, with tidy form, you would have an a variable and a b variable. And the a would say whether it's a1, a2, or a3, and then the b column would say whether it's b1 or b2. And then you would have a column for the values, 10, 9, 7, 11, 12, 6. Okay? And in this case, we have 6 rows because we have 6 different values that we want to plot. So each row represents an observation or a value that you want to plot, and each column represents the variable that we want to map. Okay, and so this is the tidy form. So if the data was given like this, and I wanted to put it into tidy form, what is the command that we would use? Yeah, we would use gather, right? Because we're trying to gather values that are spread across 3 columns. We want to gather them into 1 column. So we would use gather to create 1 column of values, and we would need to indicate our indexes and our values and our keys. And so anyway, here it is in tidy form. And now we can try to plot this. Okay, so to plot this, we're going to first call the ggplot library, of course, but then we're going to map this column of a values to the x position, and that's going to put the a1, a2, a3 along the x-axis. We're going to map the b, whether it's b1 and b2, we want that to apply to the color of the bar, whether it's going to be one color or another color. So we're going to say the b value gets mapped to the fill. The height of the bar is going to be the value. Okay, so in this case, the height is the y-axis, so we're going to map y equal to the value column. And we're going to say what we want it to draw will be bars. So we're going to say geometry or geom bar. And this is what it looks like. Okay, so ggplot, the data we're using is simple.dat long. The aesthetic mappings, we're mapping the values in the a column, a vals, to the x-axis. That's why we have a1, a2, and a3 along the x-axis. The height of the bar is the values column. So the values get mapped to the y-axis, the height. And then the color, the fill, the b values get mapped to the fill. And we're saying we want bars. Okay, don't worry about this stuff. The stat identity means use the actual value rather than trying to create some tabulation of things. So you're using the actual value in that column, and position equals dodge puts the bars side by side rather than stacking them on each other. Okay. If instead we wanted the b values to go along the x-axis, all we have to do is we just change x to b val, and we would change the coloring, the fill, to a values. That's all we have to do. We don't have to restructure our data. We don't have to transpose anything. Okay, all we do is we just change the mappings. The b values are now along the x, and then the color or the fill is now the a val. There's a question.
So the a val will, or when the fill separates the plots, is that, or it creates the 3 separate bars?
The fill creates 3 different colors. We're mapping the values in that a column or the b column in the other plot to the color that we want to be used. Okay.
So if you didn't have the fill argument, would it just stack up all 3 of those into one plot?
Let me think. It would not. Yeah, it would combine. Well, let me think. What would it do? We would not look at that variable as just not being mapped at all to any aesthetic attribute. So I'm assuming it would add up the B columns, but I could be mistaken. And it's a good question. Let's take a look.
Are those just the default colors that are picked?
Yeah, these are the default colors that are picks, and we can change the colorings to something else if we want to. Okay, and then before I test out these questions, we can change the geometry to lines. Okay, and this time here we're mapping the A values to the X column. I mean the X axis. The values are still along the Y. And for geometry lines, we're going to say the color is going to be the B values. That's going to be the groupings, okay? And we're using geometry lines here, okay? Color is spelled with a U because Hadley is from New Zealand. Yes?
What's the stat equals identity position equals dodge in the previous code?
Yeah, stat equals identity. So with geom bars, there's a few different things it can do. And identity says just use the value that you see. Don't try to do counts. Don't try to summarize the data or anything like that. Just use the value that you see there. Position equals dodge means don't stack the bars on top of each other because the default setting is to create stacked bar charts. And position dodge means put them side by side each other. But my curiosity has been piqued, so let me try this out here. Okay, I gotta load up G Cookbook. Let's see. Okay, so let's try this. Okay, so we're gonna just turn off, if I get rid of this aesthetic attribute, so we're no longer mapping the fill. And let's see. Yeah, it appears to add up the A values and puts them all together. So if I do simple dat long, so the A ones add up to, oh, it's just taking the first A that it sees. The 10, the 7, no? What is it doing? A1, why does this not look correct? A1 is 10, A2 is 11, and A3 is 12. I'm not quite sure where I'm not exactly sure what's going on here. Yeah, it's just taking the max here. It seems, which seems a little strange. I guess, yeah, it's not quite sure what to do because we're telling it to do identity, which takes basically just one value here. If I get rid of stat identity and I just say geom bars, stat count must not be used with a aesthetic attribute. Yeah, so I think I would have to do a sum here. Okay, so this is just it's getting a little bit messy here, because I would need to specify to R that it needs to kind of group these things together. Okay, well, so it's not working right now if we don't assign the values to an aesthetic. Okay, so anyway, all this to say, with base graphics, if you want to change the way your thing looks, you've got to either use entirely new commands or reshape your data. With ggplot 2, you just change the mappings. Okay, so you want to map the things to the attribute. Okay, so before we go on, let's just talk a little bit about some of the terminologies we're using. Okay, the data is what we want to visualize, and it's going to consist of variables, and the variables are stored in columns. Okay, and that's very important. We want it in tidy data. Each variable has its own column. Each thing that we want to plot has its own row. Okay, and I think that's the problem with getting rid of the getting rid of the eval or the fill attribute aesthetic thing is that now we have each row is something we want to plot, but now I basically have two of each thing, especially if I'm using stat identity here. Okay. The geoms are the geometric objects that we're going to draw to represent the data. Okay, and your most common geometries are going to be bars, lines, or points. And those are your three basic ones. You have a bunch of other geometries, and you can just go to, if you go to Google and you type in ggplot2, the second hit will be the index, which will be the kind of the help topics, okay? And this will list off all of the different geometries that you can use and all of these other things that you can use. But your basic ones will be the bars, the lines, and the points. And there's other geometries you can use which are nice, but I would say mastery of the bar, lines, and points is the most important ones. Then you have the aesthetic attributes, okay? The aesthetics are things like the X and Y position, the color of the line, the shape of the point, all of that stuff. The size of the point, those are all aesthetics, okay? And then you have the mappings, which map the data values to those aesthetic attributes. The scales control the mapping, okay, of the values to the data space. So if you think about scales, taking a numeric value and putting it on the x-axis, that's easy, right? Because it's very easy for us to visualize the x-axis as a number line, and so you've got numbers, numeric values, you got numbers, you just put them on the number line. That's easy. On the other hand, what if you wanted to take a numeric value and map it to a color? How can this be done? Okay. So now you'd need to have almost like a continuous spectrum of colors, okay? And so you can have something going from black to white, all right? So maybe, and you'd have to kind of scale your, the data, right? So you'd have to probably remap your data, or not remap, but rescale your data to go from maybe like a 0 to 100%. 0 could be black, 50% could be like this medium gray, and as you get higher and higher up, it gets lighter and lighter gray until it becomes white at 100%, okay? That's going from black to white, but you can have, any other spectrum of colors, like heat maps, it goes from like green to red, right? This is like you're breathing in toxic air is the red, and if it's healthy air, it's green, and we see that on the Weather Channel and things like that, or to indicate different temperatures around the country, it might go from blue to dark red or something like that, right? So there is kind of we do have a sense of color mappings or color scales for numeric things. I think, a common one is the green to yellow to red. There are other ones, if you can go from a categorical to color is very easy, and you can use colors of the rainbow if you want for that. And anyway, so those are the scales. Then you have guides, okay? And so ggplot will take the data and put them into visual mappings and visual things, but then for it to be useful to the viewer, you need to have something that says, oh, when you see a red point, it means this, and when you see a green point, it means this, and if you see some shade in between, it means this, and that's a guide, okay? We might call these things legends off to the side, but basically, along the x-axis, you have tick marks. That also serves as a guide. A guide is anything that gives the viewer an idea of what the data represents, or what the data looks like. So if you see the point right here, and it's at x equals 4 and y equals 6, those markers, the 4 and the 6, are guides, so you know what that data point represents. And so guides are just as important, because if you created a graph with no guides, your viewer has no reference to what the data means, right? And that's how you get misleading graphs where, along the y-axis, if it doesn't start at 0, the difference between 10 and 12 could look like the difference between 0 and 100. So, all right, so in a typical graphing scenario, you start off with your data with numerical or categorical values. And then you have geoms to represent each observation. You're going to have an aesthetic, such as a Y position, a vertical position. You have a scale, which defines the mapping from the data space to the aesthetic space, okay? And you might use a linear or log scale, okay? And, you know, we can think of all sorts of aesthetic mappings going from the data space into the aesthetic space, such as, well, I'll talk about these on these, okay? And so, as far as the data values go, you might have numerical or categorical, and as far as aesthetic things go, you can have horizontal and vertical positions, your X and Y coordinates, but you also have color, size, shape, other things there. The guides help the viewers understand what your things look like, or I'm sorry, what your graph represents as far as the data goes. And the variable types will determine the aesthetics. Okay, so certain things will only work for categorical variables. So the shape of a point, whether you want to use a circle, a triangle, or a square, that's only going to work for categorical data. Okay, if you have a numeric spectrum, you cannot map that to the shape of the point, because the shape of the point only makes sense if it's categorical. The color of a data point can be mapped to numeric values, or categorical values can be mapped to the color. Because you can say dark red means this value 0, and light red means 2, and things like that. We have a question.
So if you did so if your x and y axis were like two numerical, I don't know, for example, for the homework that we're doing, there's wins and losses on the columns.
Okay.
Those are both numbers. So could you not change it to be circles instead of or squares instead of dots or whatever?
So you can, okay. So when you want to map if you have a numeric value, you can map it to something that accommodates a numeric value. So you can map the wins to the x-axis, okay? Because the x-axis works for numeric. It also works for categorical, okay? You can map that. You cannot map the number of wins to the shape that you're going to use, because we don't have a shape that's going to represent the value 1. I mean, we might have 160 shapes, but it does not make sense to say the circle represents 1, the triangle represents 2, and the square represents 3, and I suppose on some abstract level we could say the triangle represents 3 and the square represents 4 and the pentagon represents 5, but then it's going to be really difficult to tell the difference between 160 and 162. So there's a limit to this shape thing, right? And what does a plus represent versus a decagon, okay?
Can you change the shape of all the points?
You can change the shape of all the points, okay? Or you can map a categorical attribute to the shape of the point. So for example, in baseball you have the American League and the National League, okay? And you can say American League points will be represented with squares. National League points will be represented with circles, okay? That would be an aesthetic mapping of the data to the shape attribute, because here you have two categories in the data, and they are being mapped to either squares or circles. So that's a mapping that makes sense. Or let's say you just say, you know what, instead of circles, I want all of the points to be triangles. That's no longer a mapping. That's what we just call a setting, and actually we'll talk about that in just a moment here, okay? So anyway, so some aesthetics like the shape only work for categorical variables. Something like the horizontal axis, the x-axis, works for categorical or numeric. Numeric is very easy to picture, but categorical, all you have to say is, the leftmost column is category 1, the rightmost column is category 7, and things like that go in between, okay? So, for scatter plots, both of the variables have to be numeric, and I think all this stuff we kind of understand. All right, so let's say we want to build a simple graph, okay? And so first we've got to have a data frame where each variable is in its own column, and then we're going to map each variable to an aesthetic. So here's just a very simple data frame. I've got x values, y values, and a group. 3 variables. Each are in its own column. X is numeric, y is numeric, and the group is categorical. Okay. So if I want to create a plot, first I say ggplot, and I'm doing an aesthetic mapping. I'm taking the x value column and I'm mapping it to the x axis. I'm taking the y value column and I'm mapping it to the y axis. And right now we have nothing on our plot, but this is our blank ggplot, and we can see that the scale on the x-axis and the scale on the y-axis has taken into account the range of the x values and y value columns. So that is already there. What we have to do now is we have to add geometries. So in this case, I think it makes sense to add points, and so we're going to tell ggplot we want to add some point geometries to this. Okay, so yeah, the previous slide, we have x to x value maps the x values to the x position and all of this. Okay, so if we want to create a scatter plot, we just take this previous command and we say add some point geometries, and there it adds the points. Okay, and so here we've only just mapped the x values and the y values to our data visualization. We had a third column in there, which was the groups, whether it was group A or group B. So if we wanted to do that, we can add another aesthetic mapping which says take the group and map it to the color. Okay. Over here, this is just a little bit of shorthand stuff. You can take this ggplot object and just store it in something, p or just some other variable here. Okay, and then we can say take p and add some points, and this will actually produce this exact thing because p now represents all of this, and we're just going to say add some points. Okay. Now if we wanted to do that other aesthetic mapping of taking the groups and mapping it to the color, we just say take p, add the points, but we're going to have this aesthetic mapping where the color of the point corresponds to the group. And we have done that. And it might be a little hard to see, but we've got 2 colors, the coral and the turquoise, and we can see these ones correspond to group A and the other ones correspond to group B. So this is an aesthetic mapping of that group column variable to the color of our data point. We have mappings and we have settings. Okay? If you wanted everything to just be the color blue, you can do that. However, this is now called a setting. This is not an aesthetic mapping because now all of the points will be blue, so that the color blue no longer carries any information contained in the data. Okay? Because everything is blue, it no longer tells you anything that's inside the data. And so this is just a setting, and we say the color is blue. Notice we do not have AES. AES shows an aesthetic mapping of something in the data to an aesthetic attribute. Here we're just saying we want all of the data points to be blue. So the color blue no longer tells us anything about the data. Whereas over here, the color of the point told us something about the data. It told us whether it was in group A or group B. Here it no longer does that. This is not an aesthetic mapping. This is just a setting that we want. Okay. We can change the scale, and there's some commands that I'm not expecting you guys to memorize, and so this is where the manual comes in handy. Okay, you can use scales, X continuous. All right, and this is where that graphics cookbook and Google comes in handy. You just say how do I change the scale in ggplot? You type that in, and you'll get some hits, probably from Stack Exchange, and it'll show you exactly what you need to do. Okay, but it makes it simple. You just say the scale, I want to change the limits to be from 0 to 8, and so now my X scale goes from 0 to 8. If we want to go back and change the color mappings, let's say we didn't like those colors, we can change the scale of our colors as well. Okay, so here, on our scale it was very simple. We only had 2 colors, but we can set a manual mapping, and we can say I want my two colors to be orange and forest green, okay? So we're still adding the point geometries with the aesthetic mapping, because now we are representing something in the data with a visual property. So we still want the color of the data point to represent the group in our data, but this time we're saying my colors I want to be orange and green, okay? And I don't know if you guys can see that, but this point is orange and this point is green, and it does represent something inside our data. One thing to note is that when you're dealing with ggplot, it's different from our base graphics. In base graphics, you had something called an output device. The output device default was your screen, okay? And you'd create something and it prints it or puts it out to the screen. You can change the output device, and I don't know if you guys learned this in Stats 20, but you can change the output device to like a PDF file, okay? And then you create your plots and it doesn't show up on your screen anymore, but it goes to the PDF, and then you close the output device and it saves the PDF, and now you can open it up, right? So you can do that. That's how the base graphics work. In ggplot, it creates a plot object, and then you have to ask R to print that plot object to show up on the screen, okay? And so it might feel like, oh, I didn't ask it to print anything before, but implicitly you were, because normally whenever you ask R to do 3 plus 3, it adds those things together and it prints out the results. So whenever you ask R to do something, the default thing is to print out the results. So when you work with R interactively and you do these ggplot things, it naturally prints out the result, and in this case it means drawing the plot on the screen. However, if you're running a script or if you have a loop and you want to actually produce these things, you're going to have to explicitly say print, my plot object, and that means you're going to create your plot object and you're going to say ggplot is this plus this plus this plus this, store that in my plot object, and then print out the plot object. ggplot also has stats functions, okay? Stats functions allow you to kind of transform or summarize your data. So for example, if you think about what a histogram is just kind of like a special kind of bar chart, okay? But what it's used for numeric data, and the way it works is that before you can create your histogram, if you had to create a histogram by hand, you'd first have to create another table, like a frequency table, where you've binned up all of the values, right? And you said between the values 0 and 9.9, I've got 15 values. Between 10 and a 19.9, I've got 23 values, and something like that. So you had to do some work first to create this frequency table, and then you are mapping that frequency table results to the heights of your bars when you're creating a histogram. Because this is such a common thing, we have Geom histogram, which does this automatically for us, okay? However, if we had to go back to the basics, we could create a histogram using just Geom bars, but before that we would have to run some stats functions which tell it bin up these things together, summarize our data into this thing, and then map those summary stats to the heights of the bars, okay? And if you wanted to do something other than a histogram where you wanted to summarize your data first, you'd use these stats functions, which either transform or summarize your data, okay? We're going to run out of time, and this is how far we got last time in the other class, but we'll talk about the three basic geometries, the point, the line, and the bar geometries. We'll talk about that. I'll put a survey up on Piazza, and based on their survey results, I'll either talk more about ggplot, which was what I originally had planned, or we can talk about something else, depending if everybody had already seen ggplot or not.